All right, today we're looking at the Unit 2, Lessons 8 through 10 practice quiz. The first question is a word problem, and it's about light. It says the relationship between the illumination an object receives from a light source of I foot candles and the square of the distance d in feet of the object from the source can be modeled by the equation I of d equals 4500 divided by d squared. Graph the function I of d equals 4500 divided by d squared for I is between 0 and 80 and d is between 0 and 80. So that's the first thing we have to do, is to graph this function. And then the second thing says, what is the illumination in foot candles that an object receives at a distance of 20 feet from the light source? And then what domain and range values are meaningful in the context of the problem? So the first thing we need to do is to graph the problem. Then we need to solve it for a specific value, and then we need to talk about the domain and the range. So there's three things that I'm going to be looking for in the answer to this problem. So the first thing, this problem, to graph it, is 4500 over d squared. This is one of those problems that is technically from Lesson 7, but they also snuck some Lesson 7 problems into Lesson 8. So this is like the easiest kind of problem that you would have seen in Lesson 8, where the numerator is just a constant. And whenever the numerator is just a constant and there's no variables here, your problem is going to look like one of the problems from Lesson 7. So this problem, because the numerator is positive, is going to only be in quadrants 1 and 3. And because the denominator cannot equal 0, then we have a vertical asymptote of x equals 0, which is the y-axis, so the function will never touch the y-axis. And as the function, as large x values get put into this problem, meaning in our case large values of d, large distances, the bigger this d value is, like say if you put in 1, you would just have 4500 over 1. But if d was like 8 million, then 4500 over 8 million squared would be a really small number. So that tells us that our horizontal asymptote, this is approaching 0 because the power of the variable on the denominator is larger than the power of the variable in the numerator. There's a second power here and there's no power here. When the power on the bottom is larger, then the horizontal asymptote is 0. So this function also has a horizontal asymptote of y equals 0, which is the x-axis, which put together tells us that our function will never touch the x-axis or the y-axis. And because the numerator is positive, the function will be in quadrants 1 and 3. Obviously, you only have quadrant 1 visible in this window that you were given, so your function is just going to look like this basic hyperbola curve. So that's the graph. The second part is we need to solve this equation when the distance is 20. So plugging in 20 for d, you have 4500 over 20 squared, which gives you about 11.25. And then to answer your word problem question, you need a sentence answer. And it says, what is the illumination in foot candles that an object receives? So the illumination an object receives at 20 feet is 11.25 foot candles. The third part is, what is the domain and range? What values are meaningful in the context of this problem? Well, if they tell us this window of I being between 0 and 80 and d being between 0 and 80, well, d is the domain. It's your x variable. When you plug a distance in, you get an I amount, you get an illumination. So I is the y value. So the domain and the range, since they both have the same values between 0 and 80, I said that they must be positive. They're bigger than 0. But also neither distance or illumination will exceed 80. They're less than or equal to 80. So those are the values that are meaningful in this problem. You can't have a negative distance because an object can't be negative distance from a light source. You can't have negative amounts of illumination. But also you can't have more than 80. You can't be more than 80 feet from this light source in this problem. And you can't have an illumination higher than 80. So that's how I came up with these answers. Question 2 is another problem from Lesson 8. This time we just have to graph the function. It doesn't give us any other directions. The first thing you want to look at is to pay attention to the degree of the numerator and the degree of the denominator, and notice that they're both first power things. This is x to the first power, x to the first power. So when the powers are the same of the numerator and the denominator, the horizontal asymptote is going to be equal to whatever the leading coefficients are because the powers are equal. So the leading coefficient of the numerator is 1 because it's 1x, and the denominator is also 1x. So your horizontal asymptote is 1 divided by 1, which gives us 1. The vertical asymptote is still whenever the denominator is equal to 0. And if you plugged in 2 for x, this term would become 0. So my vertical asymptote is x equals 2. So the first thing I did was to figure out my asymptotes, and then I plotted them over here. You can see that I have 2 dotted lines that represent my asymptotes. And then what I did, because I wasn't sure if the function was going to be in like the first or third quadrant parts or the second and fourth quadrant parts, so I said, well, let me see. If I plug in x is 0, what is the function? So if I plug that in, I ended up with -3 over -2, which is 3 over 2. And 3 over 2 is like 1.5, which is higher than my asymptote of 1. So since that basically made the coordinate point 0, 1.5. So if I plot 0, 1.5, that's about here. So that tells me that the graph is going to be in the second quadrant part. So I sketched a second quadrant curve for a hyperbola. And if it's in the second, it also has to be in the fourth. So I sketched this also. But then just to confirm, I said, well, if it's somewhere over here in this quadrant, that means somewhere along here it had to touch the x-axis. And anywhere where the function touches an x-axis means the y value is 0. So I said, okay, 0 is going to equal this fraction. And the only way for this fraction to equal 0 is if the numerator equals 0. And the only way the numerator can equal 0 is if x is 3. 3 minus 3 would give me 0. So that gives me the point, when x is 3, y is 0, 3, 0. Which confirmed that the graph was going to be down here in the fourth quadrant part of my asymptotes. Question 3 is a direct variation equation. It says y varies directly, so you want to write down the direct variation equation. Use the first information to solve for k, then plug your k in, and use the second information to find y when x is 33. Question 4 is joint variation, so I wrote the joint variation equation. The first thing, again, you're going to do is solve for k and then plug that information in and do the second part of the problem. Number 5 is an inverse variation equation, so I wrote that formula down. I plugged in the given information and I got k is 15. Then I plugged k in, have my new equation, and I used that to find the value of x when y was 2.5 right here. Going on to the back. Question 6, so again we have a word problem. This one says the area A of a trapezoid varies jointly as its height and the sum of its bases. So as soon as I see the word jointly, I know it's joint variation, which is in the form of, back up here on question 4, y equals kxz. It's everything's multiplied together. But instead of y, I have the area varies jointly. So I start off with area equals k, and it varies jointly as the height. So I used h for height and the sum of its bases, base 1 and base 2. A trapezoid has 2 bases. If you remember your geometry, you should already know what k is. But if you don't, then it gives you a scenario. It says the area is 480 square meters when the height is 20 meters and the bases are 28 and 20 meters. So I used that information in my formula to figure out that k is a half. And then knowing that k is a half, I wrote my formula down. And I used that to find what is the area. I found the area of the trapezoid when the height was 8 and the bases were 10 and 15. And I found out that the area was 100 meters squared. Question 7, we have an equation with fractions in it. The first thing I did was I noticed that these two fractions, this piece and this piece, have the same denominator, so I brought this thing over to the right side by subtracting. And now I have 5s plus 8 minus s, leaves me with 4s plus 8. And I noticed that these had a common factor of 4, so I factored that out. And then the s plus 2's can cancel, and so I was left with just s on the left side and 4 on the right, which told me that s was 4. Then just to make sure my work was correct, I checked my solution, I plugged it back into the original problem, and I was like, are they equal? Are they equal? And I'm just simplifying down as I go, and eventually I got to the conclusion of yes, the two sides were equal, which proves that my answer of 4 is accurate. In question 8, we have another inequality. What I did here first was to get a common denominator of 10x. So you can see in the first fraction, if I had 5x, I need to multiply that by 2 to get 10x. So I did the same thing on the top. The second fraction, I needed to multiply by x on the top and bottom. And the third fraction, I needed to multiply by 5 on the top and bottom. Once I have a common denominator for all these things, I can combine these two fractions into a single fraction of 4 times 2, which is 8, plus x, all over 10x. Now that you have a single fraction and a single fraction, you're going to make the related equation. So you're going to turn the inequality sign into an equal sign and cross multiply. That gives you this expression. I brought it up over here. I brought the 150 over to the left side. So 80 minus 150 gives me negative 70x. I factored out the common factor, which is 10x. And then times x minus 7 is going to equal 0, which gives me two solutions of 0 and 7. So on my number line, I made 0 and 7, and I'm going to check test points on each interval, so something less than 0, something between 0 and 7, and something bigger than 7. So I tested -1, and when I plugged that in the original equation, I got that the inequality was not true, so I put an X on that section. And then I tested 1, I plugged 1 in, and I got that the inequality was true, so I put a check mark. And I didn't show this, but there's basically two options for inequalities. Either you're going to have, between these 2 points, you're either going to, if there's a check mark in here, then both sides are not going to be true. And if there's an X in here, then both sides will be true. So as soon as I knew the check mark was in here, I knew both sides were not going to be true. So I didn't bother checking this side, I just knew it. And that's something I'm going to allow you to assume when you're working on the test. If the middle part is true, both end parts will not be true. So because the middle part was true, that means the x values can be anything between 0 and 7. So my solution is 0 less than x less than 7. Question 9, again, we have an equation. The first thing I did was factor this denominator over here, and I noticed that it factored into v minus 2 and v times v minus 1, which are the same things as over here. So this first fraction needs to be multiplied by v minus 2. So I have the numerator 4v times v minus 2. The second one needs to be times v minus 1. So I have 5v times v minus 1. Now my denominators match. So all I'm going to do is look at the numerators, which you can do. I multiplied this out, the 4v and the 5v, and I got all these terms equals the numerator over here, 2. Combined my like terms, and I was left with this. Over here, I multiplied both sides by -1, and then I brought the 2 over. I have this binomial, or not binomial, I have a trinomial that's a quadratic, so I factored it. A times c was 2, and I found my numbers that multiply to 2 and add to 3 are 2 and 1, so I factored it, and then I solved what number plus 1 is 0, it's -1. What number plus 2 is 0, that's -2. So those are my two answers, -1 and -2. The last question, number 10, says Kiana has made 9 of 19 free throws so far this season. Her goal is to make 60%. If she makes her next x free throws in a row, then the function can be 9 plus x over 19 plus x. That's going to represent her new ratio of free throws made. How many successful free throws in a row will raise Kiana's percent made to 60%? And is this reasonable? So I start off with the fraction that they give me, and I set it equal to 60%, which is 3 over 5 as a fraction. I'm going to cross multiply this, and that gives me this stuff. I did some algebra, and I got x is 6. So I got that she needs to make 6 free throws. Well, is it reasonable? Here's how you check if it's reasonable. You check your work. You plug it in. 6 plugged into this thing. It would give you 9 plus 6 over 19 plus 6. 9 plus 6 is 15. 19 plus 6 is 25. 15 divided by 25 is 0.6, which is the 60% we were looking for. So yeah, the answer was reasonable because it makes sense. So then I just said, as a sentence, Kiara must make her next 6 free throws to raise her percent made to 60%. So that's the whole practice quiz. The regular quiz will be next class, in class.